Hello students, welcome to our channel. Today we are going to discuss how to remember the potential and field dependency on small r in case of monopoles, dipoles and also quadrupoles. Okay, so I'll give you a shortcut here and please watch the video until ending. Okay, so let us have the heading here. That is actually it is electrostatics. Electrostatics. First of all, potential and field. Okay, potential, field, they are related actually. Potential V and field is E. The relation between potential and field you already know probably. Okay, the field E vector equals to negative gradient of the potential. Gradient means differentiation with respect to space. Okay, so if you differentiate the potential with respect to space and keep a minus sign, it will give you the field expression. Okay, so why that minus? It is very simple meaning. The minus indicates in that field there will be a force. Due to that force, the charged particle will move from high potential to low potential. That is a minus meaning. And which charged particles here? Positively charged particles, they will go from high potential to low potential. If they are negatively charged particle, then they will go from low potential to high potential. Okay, the meaning of the minus is that one. Okay, so we are going to discuss today the dependency of this potential and field on this small r due to monopoles, due to dipoles and also due to octupoles, quadrupoles. Okay, so let us have the discussion here. We are not going to prove them, prove those equations. Okay, I'm not giving the proof of those equations, but I'll give you just a shortcut how to remember that. Okay, so generally you will have the potential V and field E. Okay, and you may have monopoles, dipoles or dipole simply, next quadrupole, then octupole. Okay, so the potential due to monopole. What is monopole actually? Many of you might not know what is monopole. Okay, monopole means simply sum of charges. The algebraic sum of charge is nothing but monopole. Okay, so due to monopoles, the potential is going to be proportional to 1 by r. It is proportional to 1 by r. Okay, I hope you got it. Or otherwise you can say the equation for the potential, it is k q by small r, where k equals to 1 by 4 pi epsilon naught. Okay, and due to the same monopoles, the field proportionality is going to be, it is directly inversely proportional to 1 by r square. Inversely proportional to r square, and the field expression is going to be, it is k q by r square. Okay, coming to the dipole, the potential due to dipole, it is inversely proportional to r square. If you write completely, it is k p cos theta divided by r square. Okay, here what is p here? Small p. This is a dipole moment, right? How to calculate the dipole moment, I will explain this after this one. Okay, so due to dipole, the electric field formula will be, it will be inversely proportional to r cube, and the formula is going to be, it is kp by r cube into 1 plus 3 cos square theta. Okay, and this formula here, theta is the angle made by the r vector with respect to axis of the dipole. Okay, that we will discuss in case of proof. Quadrupole, if you consider, remember the potential due to quadrupole will be inversely proportional to r cube. Okay, and potential formula is not available. Okay, unavailable. Sorry. And in fact it is not required. Okay, so better I'll write here instead of unavailable, I can write here not required. I mean, for plus 2 level CBSE or NEET or JEE exams, okay, they will not ask you the potential due to quadrupole, but they might ask you the potential proportionality on small r of quadrupole will be 1 by r cube. Okay, and coming to the field, the electric field due to quadrupole will be proportional to 1 by r power 4, and it is also not required. The field equation is not required for NEET and JEE exams. Okay, octopole, coming to octopole, the potential due to octopole will be, maybe you can guess here. Okay, if you see the relation, it is 1 by r square, 1 by r cube. Next it will be proportional to 1 by r power 4. You're right. Okay, if you guess that. And field, this also you can guess. For monopoles it is 1 by r square, 1 by r cube, 1 by r power 4. It is going to be 1 by r power 5. Okay, and what about the formula of these, like octopole potential and also octopole field? It's okay, it's not required for the NEET and JEE exams. Okay, so don't worry about the exact formula of these two. Okay, but they can ask you the just proportionality of the V and E on small r. Okay, so you can remember easily. Suppose if the potential due to monopoles they are asking, it is inversely proportional to r, field is going to be 1 by r square. Okay, like that, if you remember this chart,